All right, we have the projectile problem solving examples. In our first example, we have a meatball rolling off a plate that is on a 5-meter tall table. It lands 0.75 meters away from the table. So over here on the diagram, here's our meatball. It's moving horizontally off the table. It's falling a vertical height of 5 meters, and it's landing 0.75 meters away from the table. So this is our horizontal velocity. So all we're going to do first is we're going to take the information that is given to us and we're going to draw them or fill it in this table here. So the first thing that we know is the vertical height of the table. The height of the table was 5 meters. Okay, horizontally that meatball landed 0.75 meters away. Okay, now a few other things that I do know that are implied, they're not given to me, are the acceleration of gravity. I know that meatball is falling downward towards the ground, and it's falling due to gravity. So acceleration vertically is negative 9.8 meters per second squared. Now, as that meatball is rolling off the table, it's rolling horizontally. So at the top of its path, it has no vertical velocity whatsoever. So its initial vertical velocity is going to be 0 because it's at the top of its path. It doesn't have any initial vertical velocity. Now, on the horizontal side, we know that the horizontal motion of this meatball is constant, okay, because horizontally gravity does not affect anything. So gravity pulls things down, not left or right. So if it's not affecting it horizontally, then that must mean that the horizontal velocity is constant. If it is constant, then that also tells me that it is not accelerating because it's not speeding up, it's not slowing down, it's not changing its direction, so it does not have any acceleration horizontally. Okay, so far we've filled in everything that we already know just based off of what information is given to us or what is implied. So all we have left to find is the time, the final vertical velocity, and the horizontal velocity, final and initial. Okay, so the one component that ties together our horizontal motion and our vertical motion is the time. So if you can find time first in most of these problems, then you're going to be able to find every other variable that's listed. So let's find time first. Now, an easy way to do this is to use the simplified equation or the rearranged equation that allows us to solve for time when we know the vertical distance. In this case, we do know the vertical distance. It is 5 meters. Okay, so that rearranged equation that is substituting or solving for time when our initial vertical velocity is 0 is t equals 2d, this is your vertical distance, your height, divided by a, all under the square root. Okay, so that is equal to 2 times, we said our height, our vertical distance was 5, divided by 9.8, all under the square root. So now I'm going to use a positive 9.8 for 2 reasons. One, I know that I cannot take the square root of a negative, and 2, I know that time is going to be positive anyway. We can't have a negative time. So for the sake of the calculation, I'm going to leave this in here as a positive 9.8. So when I multiply 2 times 5 divided by 9.8 and then take the square root of that answer, I get a time of 1.01 seconds. So I'm going to write that up here in my box, 1.01 seconds. So now that I've found time, I can find every other variable like the final velocity, initial velocity, final velocity horizontally. Okay, so let's start with the vertical velocity. I know that the final velocity is what I want to solve for. I know the initial velocity is 0. I know that the acceleration of gravity is negative 9.8. and I know that the height, the vertical distance, is 5 meters. So I know D, VI, VF is what I'm solving for, and A, that means I'm going to use the equation that says A equals VF squared minus VI squared divided by 2 times D. Now if I substitute everything in there, I get a negative 9.8 equals my final velocity squared, because I don't know it. Initial velocity, we said vertically, is 0 squared divided by 2 times our height, which is 5. Okay, so I know that 0 squared, my initial velocity is 0. 0 squared is 0. So for the sake of this calculation, instead of rewriting it, I'm just going to ignore all this. And 2 times 5, that's an easy multiplication problem right there. 2 times 5, I know, is 10. So what you ultimately end up with is negative 9.8 equals VF squared divided by 10. So I want to get VF by itself, but it's over 10. So I have a fraction on the right. I want to make a fraction on the left. So for that, I'm going to cross multiply. And I have 1 times VF squared and 10 times negative 9.8. So when I multiply negative 9.8 times 10, I get a negative 98. And 1 times VF squared is just VF squared. Well, in order to get VF by itself, I need to take the square root of both sides. So I'm going to take the square root of the right, square root of the left. Now again, you cannot take the square root of a negative value, but the negative is referring to the direction of my meatball on the way down. It's in a downward direction. So for the sake of the calculation, I'm going to take a square root of a positive 98, and when I do that, I get 9.899, which rounds up to 9.90 meters per second. That's my final velocity. And again, it's falling in a downward direction, so I need to put this negative back on here. Okay, so I'm going to fill that into my table here for the final velocity is a negative 9.9 meters per second. Alright, so we found the vertical velocity right before it hits the ground. Now I want to find the horizontal velocity throughout the entire pathway. We already said that the horizontal velocity was constant. So if I can find my initial horizontal velocity, then I know what my final is because they will be the same. So since gravity does not affect an object's horizontal motion, there's only one equation that we know so far that does not include A in it. And it is Vx, which means horizontal velocity, equals dx, horizontal distance, divided by time. Okay, in the problem, it told me that my horizontal velocity was 55. Excuse me, it's not 55. That is unknown. Wrong problem. Equals the horizontal distance, I do know, was 0.75 meters. And the time it took to fall was 1.01 seconds. And when I divide 0.75 by 1.01, I should get a velocity of 0.74 meters per second. So when I fill that in here, I get 0.74 meters per second. And since my horizontal velocity stays constant throughout the entire path, this is also 0.74 meters per second. In my next problem, I have a slingshot firing a rock with a horizontal velocity of 5 meters per second. The rock lands a horizontal distance of 30 meters away. So here's my slingshot shooting horizontally 5 meters per second following a parabolic curve, and it lands 30 meters away from where it was shot from. Okay, so let's fill in the information that we do know. We know that the horizontal distance is 30 meters. We know that the speed at which it's going horizontally is 5 meters per second. And I know that this rock is being pulled down by gravity, so this is negative 9.8 meters per second squared. I need to find time, the height, and the final velocity. Well, in the previous problem, I could find time easily because I knew the vertical distance. Here, I don't know how high that slingshot is. I don't know the vertical distance, but I do know the horizontal distance and the horizontal velocity. So our equation for horizontal motion is Vx equals dx divided by t. So I can solve for t using this equation. So I'll substitute a 5 meters per second for my horizontal velocity, 30 meters for my horizontal distance, and I want to find time. So to get t by itself, I need to set up my fraction on the left so that I can cross multiply. I get 5 times t equals 1 times 30. So 5 times t is simply 5t. 1 times 30 is 30. Now to get t by itself, one more step is to divide by 5 on this side, divide by 5 on the right. The 5's cancel here, and I'm left with t equals 30 divided by 5, which is 6. So I get 6 seconds. I'm going to fill that in to my data table. Okay, so now all I need is the height and the vertical velocity. So looking at this, I know that it's starting off horizontally. So because it's starting off horizontally, it's not traveling up, it's not traveling down yet, it's at the top of its path. I know that the initial velocity is 0. Okay, so I'm going to go ahead and add this into my table, even though there's not a space for it. I'm going to add that the initial velocity is 0. Okay, so because the initial velocity is 0, if I multiply anything by 0, I get 0. Okay, if I want to find the height, I'm going to use d equals 1/2 at squared because vi times t is 0. So this is what it looks like. So d equals vi t plus 1/2 at squared. Now if vi is 0, then 0 times anything is 0. So essentially this goes away. And all you're left with is 1/2 times a times t squared. Okay, so if I substitute, d is my height that I'm trying to find, 1/2 times the acceleration of gravity times time, which we said was 6 seconds, squared. So 6 squared times negative 9.8 times 1/2 gives me negative 176.4 meters. That's my displacement. So what that tells me is that that rock fell downward 176.4 meters. However, most often when we're referring to height, height is from the floor up. So that's a positive value. So because this is specifically listed as height, I'm going to write this in as a positive 176.4. Okay, and the last thing we need to find is the final velocity. How fast is it going right before it hits the ground downward? Okay, I know the initial velocity we said was 0. I know the time is 6. I know gravity is pulling it down. I want to solve for VF, so I would use the equation A equals VF minus VI divided by T, where A is negative 9.8. VF is unknown, VI is 0, and time is 6. Well, if VF is subtracting 0, then VF is unaffected, so I can get rid of this. So VF over 6 equals negative 9.8. All I need to do now is create my fraction on the left and cross multiply. So negative 9.8 times 6 gives me a negative 58.8 meters per second. That is my final velocity. That's how fast that rock is going right before it hits the ground. So negative 58.8 meters per second. That is the vertical velocity, how fast it's going right before it hits the ground. And the last one. Arrow shot at the target and strikes the center's bullseye. The arrow strikes the target with a vertical downward velocity of 4 meters per second and a horizontal velocity of 55 meters per second. Okay, so down here at the bottom, you can see the arrow here shooting horizontally 55 meters per second, traveling along this pathway, hitting the bullseye downward, so it's starting to curve downward at negative 4 meters per second squared. So 4 meters per second down. Okay, so we need to calculate the time it takes, the horizontal distance, and the height of the archer or the arrow. Okay, so first step here is to solve for time. So since time connects the horizontal with the vertical, we need to solve for time first. Now looking at what I have, let's fill in that information first. Almost forgot. So let's see, I have the horizontal velocity was 55. And the vertical velocity downward was a negative 4 meters per second. Now it's not written here, but I know the initial velocity at the top of its path is 0. And I know that gravity is pulling it down. Okay? So I want to solve for time. I know the initial velocity, I know the final velocity, and I know gravity. So to solve for t, I'm going to use the equation A equals VF minus VI divided by t. Okay, and if I substitute everything in there that I know A is a negative 9.8. I know VF is a negative 4. VI is 0, and T is unknown. Okay, so I have that negative up there, the 0 up there, and negative 4 minus 0 is just negative 4, so this really goes away. And so all I'm left with is a negative 4 divided by T. So I have a fraction on the right. I want to cross multiply and make a fraction on the left. So I'm going to cross a negative 9.8 times T and 1 times a negative 4. And when I do that, I get a negative 9.8 t equals a negative 4. Now, next step, I want to get this t by itself. And t is being multiplied by negative 9.8, so the opposite is to divide both sides by a negative 9.8. And when I do that, these 9.8s cancel, and t is all by itself. And I have a negative 4 divided by a negative 9.8, and that gives me a time of 0.41 seconds. 0.41 seconds. So I'm going to go ahead and put that up here in my table, 0.41 seconds. So now I have time. That I have time, I can find the height of that arrow and the horizontal distance. How far does it travel horizontally? Okay, so I'm going to start by solving for height first. Now I'm looking at this, and since I'm solving for a vertical component, then I can only use my vertical components. I can't use a horizontal velocity. So I do know the final velocity. I know the initial velocity. I know the acceleration. I want to solve for height, which is also commonly written as dy. So the height is a vertical distance. So since I know dy is what I'm solving for, I know the initial velocity is 0, and I know the acceleration and the time now, I can solve for height using the equation. I'm going to scoot this over. d equals vi t plus 1/2 a t squared. Okay? Now, our initial velocity is 0, so 0 times anything is going to be 0. So this first part goes away, so I can ignore this, and all I'm left with is 1/2 at squared. So d is 1/2 times a negative 9.8 times 0.41 squared. Okay, when I type that into my calculator and I multiply straight across, I get a displacement of negative 0.82 meters. So this is telling me that the arrow fell downward 0.82 meters. But in terms of height, which is what it's asking me here in my table here, height is generally expressed as a positive term because it's measured from the ground up. The displacement here tells me that it's from the arrow, where the arrow started, down to the target. But either one of these would be acceptable. So I'm going to write in, because it's asking me for height, I'm going to write in a positive 0.82 meters. 0.82 meters. That was my height. Okay, again, if you calculated a negative 0.82, that is acceptable. So the last thing I need to solve for is the horizontal distance. This is also known as dx. Okay, so there's only one equation that I can use to solve for any of these horizontal components, and it's Vx equals dx divided by t. I have horizontal velocity, I have time, I can solve for d. So Vx equals dx divided by t, where my horizontal velocity is 55. My horizontal distance is unknown, and my time is 0.41. Well, I have a fraction on the right. I want to form a fraction on the left, so I'm going to cross multiply. And a 55 times a 0.41. Did I miss the point? I did miss the point. This is a 0.41. 55 times 0.41 gives me 22.55 meters, and that is equal to my horizontal distance. So that's how far the arrow actually went. So in my table, my horizontal distance is 22.55 meters. Okay, on the back side, we have our scenario where the cannonball is being shot straight up out of a cannon in the bed of a truck traveling with a constant speed. How long did it take the cannonball to reach its path? What was the total time? How high did the cannonball get above the truck? Okay, so based off of this scenario, we have to answer these three questions here. So let's look at what we have here. I'm going to zoom in just a little bit. Okay, so what I see here is a velocity of the cannonball going up, and the truck has a velocity moving to the left. So this going up is my vertical velocity, and moving to the left, this is my horizontal velocity. Okay, so essentially this is Vy and this is Vx. Now, I also know that as this cannonball goes up, gravity is going to slow it down, and on the way back down, it's going to speed up. So I know the acceleration of gravity is negative 9.8, and I also know that the velocity of the cannonball at the top of its path is going to be 0. Okay, so based off of this information, I can calculate how long it's going to take to reach the top, the total time, and how high the cannonball got above the truck. So how long did it take? Well, it's asking how long it took to get from the bottom all the way to the top of the path. Now, if we want to know how long it takes to get to the top of the path, we also know the velocity at the top of the path. We know its initial velocity. We know this will be essentially the final velocity. We know gravity is pulling it down. I want to solve for t. So my equation becomes A equals Vf minus Vi divided by t. Okay, where A is a negative 9.8, VF at the top of the path is 0. The initial velocity at the bottom of the path was 39.2, and the time is unknown. So I need to cross multiply. Set this up over 1, cross multiply here and here. So a negative 9.8 times t gives me negative 9.8 t equals. And when I cross the 1 times 0 minus 39.2, well, 0 minus 39.2 is a negative 39.2. So 1 times a negative 39.2 is simply a negative 39.2. Now I need to get t by itself on the left. So I'm going to do the opposite operation, and that's to divide by 9.8 on both sides. So these cancel, and I'm left with t all by itself. And a negative 39.2 divided by a negative 9.8 gives me a time of 4 seconds. So it takes 4 seconds to reach the top. So we need to know that to answer the next question. So here's what's happening. That cannonball is going up, it's reaching its highest point and coming back down. Well, if it took 4 seconds to go from the bottom to the top, then it's going to take an additional 4 seconds to go from the top back down to the bottom. So if it's asking me for the total time, all I need to do is add those two times together. And when I add 4 plus 4, I get a total time of 8 seconds. So how high did the cannonball get above the truck? Okay, so again, I know how long it took to reach that top of the path. I want to know the vertical distance of that path, so I want to know how high it is from here down to the floor. So that's a vertical distance. Okay, so I want to know d. I still know the velocity at this point. The velocity at the top of this path is 0. I know its initial velocity. I know this will be the final velocity. I know gravity is slowing it down, and I want to solve for d. So the equation that includes all those variables is a equals vf squared minus vi squared divided by 2d. When I plug everything in, I'm going to zoom in just a little bit here. When I plug everything in, I get a negative 9.8 equals 0 squared, the velocity at the top, equals 39.2 squared divided by 2 times d. Okay, so I need to cross multiply. Negative 9.8 times 2d gives me negative 19.6 d equals, and then on the right side, I put this over 1, cross multiply here, negative 39.2 squared. So 39.2 squared gives me 1,536.4, and this would be a negative. So my next step is to get d all by itself. Well, if d is being multiplied by negative 19.6, I need to do the opposite, and that is to divide by negative 19.6. So that gives me d all by itself, and 1,536.4 divided by negative 19.6 gives me positive 78.4 meters. So that's how high that cannonball got. Okay, so relative to the truck, we saw this demonstration. Because the ball has horizontal velocity as well, its inertia is going to allow it to maintain a constant velocity all the way up and down its pathway. So when this ball comes back down, it is going to land back inside the cannon. Okay, answer choice C. Next, we want to know the horizontal distance. The horizontal distance. So how far horizontally did it get? So here's my pathway. I want to know how far I went from here to here. Horizontal distance. And I know everything I already talked about. Okay, so there's only one equation for horizontal distance, and it has Vx, dx, and t. Okay, up at the top, I'll zoom out here just a little bit. Up at the top, I already know the horizontal velocity. It was given to me. It's 3. 3 seconds to go, 3 meters per second to travel horizontally. If I want to know the distance that it covers from here to here, I need to know the time that it takes to go up and come back down to here. So I end up with 3 equals dx divided by my total time. My total time, which was, 8. So to cross multiply, 3 times 8, 1 times dx. 3 times 8 gives me 24. And 1 times dx is just dx. 24 meters is my horizontal velocity. My horizontal distance. Okay, next I want to know the resultant velocity as the cannonball fell back into the cannon. Well, I'm starting off with an initial vertical velocity of 39.2 and a horizontal velocity of 3. Now, this ball is going to go up and come back down. And remember, each side of the parabola mirrors the other side. So if on the way up I have a positive 39.2, on the way back down I'm going to have a negative 39.2. But my horizontal velocity stays constant, so it's going to be 3 throughout the entire pathway. Okay, so the equation for my resultant velocity is VR equals Vx squared plus Vy squared, all under the square root. So my horizontal velocity, we said, stays constant. So that is 3 squared plus my vertical velocity was a 39.2 on the way up. So on the way down, it's a negative 39.2 squared, all under the square root. Okay, so when I take a 39.2 squared and then add 3 squared, I should get a resultant velocity of 39.31 meters per second. Now remember, this object, this ball, is coming back down into the cannon. So it's asking me for the resultant velocity as it falls back in the cannon. So that's in a downward direction, so this needs a negative. So there's your velocity, your resultant velocity as it comes back into the cannon. Now the last one is asking for the resultant velocity at the highest point. Okay, so at the highest point, we have a velocity, vertical velocity of 0. But it's still moving horizontally at 3 meters per second. Okay, so the resultant velocity says that Vx squared plus Vy squared, all under the square root, will give me that resultant velocity. Okay, my horizontal velocity is 3. My vertical velocity at the highest point is 0, all under the square root. Well, 0 squared is 0, and 3 squared is 9. If I take the square root of 9, my resultant velocity is simply 3. Okay, because that's the only real velocity that we have at that highest point. Therefore, that is the resultant velocity, 3 meters per second.